Number 11, we need to find the unit rate or the rate of change slope in both functions. Well, the first one, the slope is given to us. It's right here. It's 18. The second one is also given to us. It's 23. So clearly, when we compare them, one of these is higher than the other. So what is this problem talking about? This is distance per hour. So like miles per hour. But in this case, it's meters per hour. A meter is like about this big. So this person, or whatever this is, this animal, maybe it's like a turtle or a snail, goes 18 meters every hour. So this one is 18 meters per hour. That's its unit rate, because that is per 1 hour. Tell me what this one is, and then tell me which one is larger, which one goes faster. Number 12. We're going to graph these two lines and find the solution, which is where the lines cross each other. So if I'm going to graph this top one, these are in standard form. So what we're going to do is we're going to use the intercepts. So my x-intercept and our y-intercept. That's for the top one. Our x and our y for the bottom one. So let's do the x for the top. It tells us right here, because if I'm talking about this x-axis, the y value is 0, and 2 times 0 is nothing. So what we'll do is we'll just ignore that this is here. X equals 8. And our y-intercept is where x is 0. We'd have to divide both sides to solve this. We get y equals 4, because 2 times 4 is 8. So y will be at 4. So the x is at 8. 1, 2, 3, 4, 5, 6, 7, 8. The y-intercept's at 1, 2, 3, 4. For the next one, the x-intercept is where this 2y is gone. That'll be at 10. And the y-intercept is going to be 5. Go away. So x is going to be 10, y is 5. So for our next line, we'll be at 10 and 5. And now we want to find where these two lines are going to cross. So we'll draw the lines. So there's our pink line. This one's mean. There's our purple line. Notice that it's going to be way up here. So my new direction for this problem is going to be to go to Desmos.com and graph these two lines and find where they cross. You'll have to move the screen around a little bit because this graph didn't really work for, it's way up here where our line intersects. And for the last one, so let's clear this tool out. We don't need that anymore. For number, not the last one, this is number 13. We need to determine, is this linear or nonlinear? Well, it kind of looks like these are pretty much a straight line. Is it positive, negative, or none? Positive goes up, negative goes down. So this is linear, this is positive. And if it's linear, write an equation. Well, y equals mx plus b. Here's our b at 2. And it looks like we go up 1 over 2 every time. Up 1 over 2, up 1 over 2. So b is at 2, m is a half. So use these numbers, plug them into this equation, and then you got your equation. For number 14, we need to use the Pythagorean theorem, which is what we are starting in class this week. We learned that a squared plus b squared equals c squared. So c is always our longest side. Is it possible that we have a triangle, a right triangle, that uses these sides? 10 squared plus 8 squared, is that 12 squared? Well, let's see. This is 100. This is 64. And this is 144. Is 164 equal to 144? Nope. So this is not possible.